Electrical exam preparation necessitates a comprehensive understanding of the National Electrical Code, or NEC. The NEC is a critical safety standard governing electrical installations, ensuring the protection of people and property. Approaching exam preparation with integrity and dedication is paramount. Attempting to bypass the learning process by seeking unauthorized access to test questions and answers is not only unethical, but also potentially dangerous. The purpose of the electrical exam is to assess an individual's knowledge and competence in applying the NEC to real-world scenarios. Circumventing this process undermines the validity of the certification and can lead to unqualified individuals performing electrical work. Instead of seeking shortcuts, focus on a structured and thorough approach to learning the NEC. Firstly, obtain the most current edition of the NEC. The NEC is updated every 3 years, so ensuring you have the latest version is essential. Secondly, familiarize yourself with the structure and organization of the NEC. The NEC is divided into chapters, articles, and sections, each addressing specific aspects of electrical installations. Thirdly, begin by studying the foundational articles and definitions in Chapter 1. This will provide a solid base for understanding the more complex requirements in subsequent chapters. Fourthly, pay close attention to the definitions provided in Article 100. Accurate interpretation of these definitions is crucial for applying the NEC correctly. Fifthly, move on to Chapter 2, which covers wiring and protection. This chapter includes essential requirements for overcurrent protection, grounding, and wiring methods. Sixthly, thoroughly understand the requirements for overcurrent protection devices, such as circuit breakers and fuses. These devices are designed to protect electrical systems from overloads and short circuits. Seventhly, master the grounding and bonding requirements outlined in Article 250. Proper grounding and bonding are critical for electrical safety and preventing electrical shock hazards. Eighthly, study the various wiring methods permitted by the NEC, including conduit, cable, and raceway systems. Each wiring method has specific requirements for installation and support. Ninthly, explore Chapter 3, which addresses wiring methods and materials. This chapter provides detailed specifications for the types of conductors, cables, and raceways that are permitted in different applications. Tenthly, understand the ampacity ratings of conductors and their allowable uses. The ampacity of a conductor is its current carrying capacity, which must be carefully considered to prevent overheating and fire hazards. 11thly, review the requirements for box fill and conductor fill in enclosures. Overfilling enclosures can lead to overheating and damage to conductors. 12thly, delve into Chapter 4, which covers equipment for general use. This chapter addresses a wide range of electrical equipment, including receptacles, switches, and lighting fixtures. 13thly, familiarize yourself with the requirements for installing receptacles and switches in various locations. The NEC specifies different types of receptacles and switches for different applications, such as GFCI-protected receptacles in wet locations. 14thly, study the requirements for lighting fixtures, including the types of fixtures permitted in different environments. 15thly, examine Chapter 5, which focuses on special occupancies. This chapter addresses the unique electrical requirements for hazardous locations, healthcare facilities, and other special occupancies. 16thly, understand the classifications of hazardous locations and the types of equipment permitted in each class. 17thly, review the requirements for healthcare facilities, including the essential electrical systems that must be provided to ensure patient safety. 18thly, dedicate time to practicing electrical calculations. Electrical calculations are essential for determining conductor sizes, overcurrent protection, and voltage drop. 19thly, master Ohm's law, which is the fundamental relationship between voltage, current, and resistance. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. 20thly, learn how to calculate voltage drop in electrical circuits. Excessive voltage drop can lead to equipment malfunction and reduced efficiency. 21stly, understand how to calculate the short circuit current available at different points in an electrical system. Short-circuit current calculations are essential for selecting the appropriate overcurrent protection devices. 22ndly, utilize available resources such as study guides, practice exams, and online forums. These resources can provide valuable insights and help you identify areas where you need further study. 23rdly, consider enrolling in an electrical exam preparation course. A good course can provide structured learning and expert guidance. 24thly, practice answering sample questions under timed conditions. This will help you develop your test-taking skills and manage your time effectively during the actual exam. 25thly, review the NEC frequently and consistently. Regular review will help you retain the information and build your confidence. In addition to studying the NEC, it is also important to develop a strong understanding of electrical theory and safe work practices. Firstly, understand the principles of electricity, including voltage, current, resistance, and power. Secondly, learn about different types of electrical circuits, such as series, parallel, and series parallel circuits. Thirdly, familiarize yourself with the operation of common electrical components, such as resistors, capacitors, and inductors. Fourthly, develop safe work practices, including lockout-tagout procedures and the use of personal protective equipment, or PPE. Fifthly, always de-energize electrical circuits before working on them. Sixthly, use appropriate PPE, such as insulated gloves, safety glasses, and arc-rated clothing. Seventhly, follow lockout-tagout procedures to prevent accidental energization of electrical circuits. Eighthly, be aware of the potential hazards associated with electricity, such as electrical shock, arc flash, and electrocution. Ninthly, never work on electrical equipment while standing in water or on a wet surface. 10thly, inspect electrical tools and equipment regularly for damage. 11thly, report any unsafe conditions to your supervisor immediately. 12thly, attend safety training sessions regularly to stay up to date on the latest safety practices. 13thly, remember that electrical safety is everyone's responsibility. By following these guidelines, you can prepare effectively for the electrical exam and ensure your safety and the safety of others. Furthermore, consider the following additional aspects of NEC knowledge. Firstly, Article 90.3 Examination of Equipment for Safety. This section mandates that electrical equipment be evaluated for safety by a qualified testing laboratory. The listing or labeling of equipment by organizations like Underwriters Laboratories UL signifies compliance with established safety standards. Secondly, Article 110.2 Approval. Electrical equipment must be approved for the specific installation and application. This approval ensures that the equipment is suitable for its intended use and meets safety requirements. Thirdly, Article 110.3b Installation and Use. Listed or labeled equipment must be installed and used in accordance with any instructions included in a listing or labeling. These instructions provide critical information regarding proper installation, operation, and maintenance. Fourthly, Article 210.8 Ground Fault Circuit Interrupter Protection for Personnel. Ground fault circuit interrupters, or GFCIs, are required in specific locations to protect personnel from electrical shock. These locations typically include bathrooms, kitchens, and outdoor areas. Fifthly, Article 210.12 Arc Fault Circuit Interrupter Protection. Arc fault circuit interrupters, or FSIs, are designed to protect against electrical fires caused by arc faults. FSIs are typically required in dwelling units, particularly in bedrooms and living areas. Sixthly, Article 215.2 Minimum rating and size for feeders. Feeder conductors must have an ampacity rating sufficient to carry the calculated load. This rating ensures that the conductors will not overheat or become damaged due to excessive current flow. Seventhly, Article 220.12 Lighting load for non-dwelling occupancies. The NEC provides specific requirements for calculating lighting loads in non-dwelling occupancies. These calculations are based on the type of occupancy and the square footage of the space. Eighthly, Article 220.14 Other loads all occupancies. The NEC outlines various requirements for calculating other loads in all occupancies, including receptacles, appliances, and motors. 9th, Article 230.42 Minimum size and rating for service conductors. Service conductors must have an ampacity rating sufficient to carry the calculated load. This rating ensures that the service conductors will not overheat or become damaged due to excessive current flow. 10th, Article 250.50 Grounding electrode system. All grounding electrodes that are present at each building or structure served must be bonded together to form the grounding electrode system. This bonding ensures that all ground electrodes are at the same potential, minimizing the risk of electrical shock. 11th, Article 300.4 Protection against physical damage. Wiring methods must be protected from physical damage. This protection may include using conduit, raceways, or other protective measures. 12th, Article 310.15 Ampacity tables. The NEC provides ampacity tables that list the allowable ampacities of conductors based on their size, insulation type, and ambient temperature. 13th, Article 314.16 Number of conductors in outlet device, and junction boxes, and conduit bodies. The NEC specifies the maximum number of conductors that are permitted in outlet device, and junction boxes, and conduit bodies. Overfilling these enclosures can lead to overheating and damage to conductors. 14th, Article 404.2 Location of switches. Switches must be located so that they can be operated safely and conveniently. The NEC specifies the minimum and maximum mounting heights for switches. 15th, Article 406.4 General installation requirements for receptacles and cord connectors. Receptacles and cord connectors must be installed in accordance with the NEC requirements. These requirements include proper grounding, polarity, and mounting. 16th, Article 408.8 Available short-circuit current. Switchboards, switchgear, and panel boards must be marked with the available short-circuit current. This marking helps to ensure that overcurrent protection devices are properly selected to protect against short-circuit currents. 17th, Article 430.22 Single motor. Conductors supplying a single motor used in a continuous duty application must have an ampacity of not less than 125% of the motor's full load current rating. 18th, Article 430.52 Motor short circuit, ground fault, and overload protection. Motors must be protected against short circuits, ground faults, and overloads. The NEC specifies the types of overcurrent protection devices that are permitted for motor protection. 19th, Article 440.6 Selection of ampacity. Where the equipment is marked to indicate that the branch circuit selection current is to be used, the conductor ampacity shall be not less than the branch circuit selection current. 20th, Article 450.3 Overcurrent protection. Transformers must be protected against overcurrent. The NEC specifies the types of overcurrent protection devices that are permitted for transformer protection. 21st, Article 500.8 Equipment. Equipment shall be marked to show the class, division, and group for which it is suitable. The marking shall be visible after installation. 22nd, Table 310.16 Allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius. This table provides the allowable ampacities of insulated conductors based on their size, insulation type, and ambient temperature. It is a crucial tool for determining the appropriate conductor size for a given application. Remember to consult the specific edition of the NEC that is in effect in your jurisdiction. Electrical codes and regulations can vary from place to place, so it is important to be aware of the local requirements. A qualified electrician will also be knowledgeable about local amendments to the NEC. Proper exam preparation involves not only memorizing code requirements but also understanding the underlying principles and rationale behind them. This deeper understanding will enable you to apply the NEC effectively in a variety of situations. The electrical work is inherently dangerous, and shortcuts can have serious consequences. Invest the time and effort necessary to gain a thorough understanding of the NEC and safe work practices.